त्याला आपण खेळ म्हणलंय ना आले ना तो शाळेत ना आता बस बर
Good afternoon, students. Good afternoon. So let's wait for 2 to 3 more minutes for others to join, and then we will start the class. Okay. So just stay in the call only. Hi, Vaishnavi. You have raised your hand, it seems. Wanted to ask anything? Okay. So let's start with the today's session. Very good afternoon, students. Good afternoon to all of you. So can you able to hear my voice? Am I audible? Yes. Yes, actually. Thank you so much for your response. And let's, yeah, thank you, my dear. Thank you. Fine. So let's continue with the electrochemistry. Okay. So yesterday we have, so let me recap the thing that we have discussed yesterday in electrochemistry. Okay. So yesterday we have studied about the electrode potential, right? And what is electrode potential? It is the potential difference developed between the electrode, that is cathode and anode, and the electrolyte, right? So this is the electrode potential, which is represented by the letter E naught. And higher the standard potential, higher will be the tendency of the substance to get reduced. Means I told you know, if the value is more positive, then that particular substance can get reduced easily. And vice versa, lower the reduction potential, higher will be the tendency of the substance to get reduced. Okay, to get oxidized, to get oxidized. So now lower the reduction potential more negative, higher will be the reactivity of the metal also. So if the reduction potential value is very low, then that particular substance can get oxidized easily and it is more reactive also. Okay, so these three relations we have discussed yesterday, and also we have studied one formula to find out the E naught cell. No, so it is equal to E naught of cathode minus E naught of anode for the reduction potential values. And also we have studied one relation which relates the Gibbs free energy and E naught cell. So can anyone tell me that formula which relates Gibbs free energy delta G naught and E naught? So let me see who is trying for this. So at the end of the lesson, yesterday, I told you know, I gave one formula and also we have discussed the feasibility of the reaction under that topic. Like if delta G is less than zero, what is going to happen, whether the reaction is spontaneous or not. And if it is greater than zero, what is the case? And if it is equal to zero, what is the case? So those things I have discussed, right? So those things were discussed based on one formula which relates delta G naught and E naught. So what is that formula? Can anyone give me that formula in the chat box? Not even a single student. Remember that. You did not note down that formula in your notebooks. Okay, Sakshi haven't attended the yesterday's class. No problem, my dear Sakshi. So yesterday's class recording is there in YouTube channel. You can go through the yesterday's lecture over there. Okay. So in Chemistry Avanti Live 2 channel, you can see to that lecture and you can get an idea. Got it? What about the others? What about the others who have attended the yesterday's class? So none of you remember the formula which relates Gibbs free energy and electrochemical potential value. But okay, at least from today onwards, try to listen to the lecture properly and take down the notes. Okay, students? So don't just stay like this. Please take the notes. It will be helpful for you during your examination time. Okay, consistency is very, very important. If you don't take the notes in these days, then it will be a trouble only. Yeah, so it is like waste of time only. So don't do like this. Try to keep a notebook with you and have a pen with you and write down all the points which we are studying in all the subjects. Got it? So let me give the relation. It is delta G naught cell is equal to minus NF E naught cell, where delta G is the change in Gibbs free energy and N is the number of moles and F is the Faraday's constant. I told you, no, Faraday's constant value is 96,500. So that is the constant value which you have to memorize. And E naught cell is the electrode potential value. Okay. So these are the things we have covered in yesterday's class. Now, in today's session, we are going to discuss about the Nernst equation and applications of Nernst equation. And if time permits, we can go with the electrolytic cell, Faraday's laws, and the product of electrolysis. Okay. So let's start with the Nernst equation. Nernst is the name of the scientist. Okay. Nernst is the name of the scientist. And it is based on, the equation is based on the galvanic cell, the same galvanic cell. And this is that person, Nernst person. Okay. And what he took two beakers. And in two beakers, we have two solutions. And in the first beaker, we have a blue colored solution. And it generally it is denoted by n power n plus. And this is n plus, ion. Both of them are ion. Okay. And the reaction which is going on inside those two beakers is represented like this. So Mn plus one metal ion is trying to react with one solid metal, and it is getting converted to M and N plus. So what is happening here? Metal M atom is getting, ion is getting reduced and N is getting oxidized. Like zinc and copper, you can take this as M and N. Okay. And here the delta G, that is the change in Gibbs energy for this particular reaction is denoted by delta G cell, which is equal to delta G naught cell plus RT LNQ plus RT LNQ. Okay. So here we know that delta G is nothing but NFE. So delta G is NFE and delta G naught is NFE naught. So these two are the relations which we are getting from the yesterday's concept that we have studied. Okay. Now what you do, substitute these two values here in the place of delta G and delta G naught. So this particular equation will become like this: minus NFE cell equal to minus NFE naught cell plus RT LNQ. Okay. Suma, am I not audible? Students, what about the others? Am I audible to others? Can others able to hear my voice? Yes. What about others? Sakshi can able to hear my voice. I think only Suma. Suma, you have some network issue, I think. I do have some network issues. That's why I have turned on off my video today also. So from tomorrow onwards, it will be rectified. Okay. Yeah. But I'm audible, right? I'm audible to Sakshi and I'm audible. Can any other student other than Sakshi can reply me whether am I audible or not? Vaishnavi, hi Vaishnavi. Can you able to hear my voice? Am I audible to you? You can give your answer in the chat box itself. One of you can reply me. You can able to hear, then it is the problem with Suma's side, I think. Suma, check your network, okay? So come to the place where you get good. Sanskruti. Okay, Sanskruti can also able to hear. Okay, fine, students. Fine. Suma, just check your network, my dear. Go to the place where you get a good internet connection, okay? Fine, let's continue with the class. So what we were doing, yeah. So in place of delta G and delta G naught, we are substituting NFE and NFE naught. And finally, we have got one equation. Okay. So here, since left hand side and right hand side contains the same term NF and NF, I can cancel. So otherwise, what I can do, I can divide this entire equation by NF. Okay. Minus NF. So if I divide this entire equation by minus NF, I will get E cell, which is equal to E naught cell. And here, since I have divided this by minus NF, it will become like minus RT by NF into ln Q. Okay. And this is the very important formula which we have to keep in mind. Got it? So, students, can you all able to understand till this equation? Can you understand the 5 steps that is there on the screen? All of you? Yes. I want a reply from others also. Okay. Don't stay silent. If you are not getting anything, just reach out to me. I will explain you again. Got it? So listen to the class properly. All of you. All of you. Thank you, students. Thank you so much for your interaction inside the class. Okay. So keep the spirit till the end. So till this, all of you have understood. Now let me move on to the next slide. So coming to the next slide, I'm going to take the same equation. And in the previous equation, we had Q. Q is nothing but the reaction quotient. You might have studied about the reaction quotient and all in the class 11 equilibrium lesson last year. Okay. So it is equal to, reaction quotient is equal to, or it can be written as oxidized ion concentration divided by the reduced ion concentration. Okay, and here you see this particular metal ion has been reduced from N plus. Suma, my voice is not coming only for you, my dear. So just check your network connection. I am audible to others. Okay, let me put up a message for her and then I'll come back to you. Students, just wait here. Yes. Okay, students, just see to the equation here. See to the equation here. So metal is having some oxidized form which is N plus. Okay. For example, I'll take this. Yeah. So here, if this is some metal ion with 2 plus oxidized form, and if this is some N metal, then it is getting converted to M, and N is taking those 2 electrons. Okay. Now here, if you see, M2 plus is getting converted to M. So the oxidation state of M is 0 and the oxidation state of this here ion is +2. So there is the decrease in the oxidation number. So what it is called? It is called as reduction. Okay, so it is called as reduction. Mn plus have been undergone reduction. And what about this N atom? N metal have got oxidized from 0 state to 2 plus state. It has lost 2 electrons and it has got oxidized. So this is the oxidized ion. Okay. So as I have already told you, the reaction quotient Q has to be written like or written as the oxidized ion concentration divided by the reduced ion concentration. So it is N plus concentration divided by Mn plus concentration. Okay. Now what you do, substitute this Q value in the previous equation. In place of Q, substitute this value. Okay, substitute this. Where F is the Faraday's constant and whose value is 96,500 coulomb per mole, and lna is nothing but 2.303 log 8. So to convert ln to log, we have to multiply by the number 2.303. Okay. And if you take the temperature as 298 Kelvin, if we take the temperature as 298 Kelvin and substituting all the values, T value, R is the universal gas constant. So substituting the R value, T value and F value here and converting ln also into log, we will get one number. Okay, and if we multiply those things, that number is 0.059 divided by n, where n is the number of electrons lost or gained. And for this particular example which I have given here, what is the number of electrons lost? It is 2, right? So the number of electrons lost is 2 and number of electrons gained is also 2. So the n value is 2 for this particular reaction. So according to the equation, that n value changes. But R, T, F, these three terms are constant, they are fixed value. And also to convert this L into log, we have to multiply the entire thing with 2.303. Okay. And by doing so, by doing R into T into 2.303 divided by F, we will get one number and that number is 0.059. Okay. Okay. Ravi Kumar Patel, don't turn on your audio. Okay. If you are getting any doubt, just give that in the chat box. Fine. So multiplying all the constant values, we are getting the 0.059 divided by n into log of the corresponding concentration. And this is the final equation. Okay. In place of n and m, we can substitute q also. So according to the question, we will be using the equations. Okay. If the reaction quotient is given in the question, then we have to use the second relation. If only the concentrations are given in the question, then I have to use this first relation. So these two relations are called as, or these two equations are called as Nernst equation. Okay, very, very, very important equation. Very, very, very important equation. So based on this equation, many numericals, okay, many numericals will come and they are very, very important for your board exam as well as for your NEET and JEE exams. Got it? So study the formula properly and thoroughly. So let's do one question based on this formula. So students, can you understand? Can you understand this Nernst equation? I think the derivation part is clear to all of you who are watching. So do any of you have any doubts till now? Can you understand how we are arriving at this Nernst equation? And try to memorize this equation, okay? Because you have to apply this in the numericals for competitive exams. Yeah. Okay. Okay, students. Thank you for your response. Now let's go with the question. So the question is, write the expression of Nernst equation for the following galvanic cells. So we have two cells, okay, two cells. The IUPAC representation of two galvanic cells are given to us, and we have to write the Nernst equation expression for these two. Okay, so how to do? So let's start from the first. Let's go with the solution. So here is the Nernst equation. In terms of Q, this is the Nernst equation. And this is the first galvanic cell which we have in our question. Okay. Now, if I want to convert this IUPAC representation of a galvanic cell into the chemical equation, how I have to write? Who is getting oxidized here? Iron is getting oxidized and silver is getting reduced. Iron is getting oxidized from 0 to +2 and silver is getting reduced from +1 to 0. So the reaction should be written like this. Fe plus 2Ag plus will give Fe2 plus and 2Ag. Okay. So this is the reaction and the concentrations of each species are also given. That is written inside the bracket also. Okay. So here, what is the N value? What is the N value here? Number of electrons lost. So iron is having 0 oxidation state and here iron is having +2 oxidation state. So the number of electrons lost is equal to 2. Okay. Since the number of electrons lost is equal to 2, the number of electrons gained should also be equal to 2. So that's why I am putting 2 Ag plus. Is it 3? Sakshi, is it 3? How it can be 3? It is not 3, my dear, it is 2. Okay. Here you see Ag plus is getting converted to 0. So only one electron is gained by Ag. So number of electrons lost and number of electrons gained. Number of electrons lost should be equal to the number of electrons gained. Okay. So that's why we are multiplying this A with 2. So it will become 2 plus 2. So 2 electrons will be gained. Okay. Students, don't turn on your audio. If you are getting any doubt, just put that in the chat box. Clear? Fine. So n value is equal to 2. Sakshi, can you able to understand why n value is equal to 2? It is not 3, it is 2. I hope it is clear now for you. And the Q value. So how to write the Q value? The oxidized ion concentration divided by the reduced ion concentration. So oxidized ion is iron. Yeah. Oxidized ion is iron, Fe. So it is going from 0 to plus 2. 0 to plus 2. 0 to plus 2 means 0 to plus 2 means it is the oxidized ion. And the reduced ion is Ag. And since we have 2 moles of Ag plus, that 2 has to go to the power. So Ag plus ion concentration raised to its power 2. Okay. Now take the Nernst equation. E cell is equal to E naught cell minus 0.059 by 2 into log of the corresponding concentration. Now we are not provided with any E naught cell, but we know one formula to find out that E naught cell, right? Yes or no? What is that formula? E naught of cathode minus anode, no? E naught of cathode minus anode. So that formula has been applied here and the corresponding ions couple, they have been represented here, and this is the Nernst equation expression for the given galvanic cell, first cell. Clear? Now let's go with the second cell. So this second cell can be written like this, because zinc is getting oxidized to zinc 2 plus and chromium 3 plus is getting reduced to chromium. Okay, zinc is losing 2 electrons according to this equation, but chromium is gaining 3 electrons. So number of electrons lost is not equal to the number of electrons gained. So what I have to do? I have to, since zinc has lost 2 electrons. 2 electrons are lost by zinc. And when you talk about chromium, 3 electrons are gained by chromium. So to make it equal, multiply zinc by 3 and chromium by 2. Okay. So we will get 3 into 2, 6. So in the equation, so we are putting 3 zinc, okay, and 2 chromium, so that the charge will be balanced. Number of electrons lost and gained will become equal. Okay. So how many electrons are lost or how many electrons are gained now? What is the n value for this equation? Can anyone tell me the n value for this equation? After multiplying by the corresponding number, what is the number of electrons lost? Very good, Suma. It is 6. Great. It is 6. And the Q reaction quotient can be written like this. The oxidized ion is zinc 2 plus. And since we have 3, it is going to the power, and chromium 3 plus power 2. Okay. And the corresponding E naught E cell value is reduced. I mean E naught of cathode minus E naught of anode minus 0.059 by 6, the log of Q. Okay. So this is how we are representing the given into the Nernst equation. Is it clear for all of you? Do any of you have any doubts from this question? Shall I move on to one more question? Do any of you have any doubts, students? Is it clear? Is this question clear to all of you? Okay. So Mahek, this no is for what? You have doubt or you don't have doubt? You have deleted your message. Okay. What about the other students? Sakshi, Suma, Ashwin, Janisha. And who is that Mr.? I don't know that Mr. Kindly keep your name. Nikita, Pranati, Rajnandani, Golab, Sanskruti, Tejaswini, Vaishnavi. That's all. What about you guys? Is everything clear? No doubt. Okay, students. Now let's move on to one more question in which we are going to find out the cell potential. Okay. Calculate the cell potential of the following galvanic cell. What is meant by cell potential? E naught cell. We have to find out the E naught cell value. Okay. And the cell is also galvanic cell is given, and the E naught values are given for the oxidized ion and for the reduced ion. So now to start with the solution, I have to convert this cell into the desired equation. Okay, since zinc has got oxidized, I am putting zinc, giving zinc 2 plus, and silver is getting reduced, and balance that number of electrons lost and gained should be equal. No, so 2 Ag plus is giving 2 Ag. So now the reaction is ready. What is the number of electrons lost? It is 2. So N value is equal to 2, and Q is nothing but the oxidized ion divided by the reduced ion, and their corresponding concentrations are also given. So the square bracket denotes the concentration, right? So the concentration of zinc 2 plus in terms of molarity is given in the equation. It is 0.1, and the concentration of Ag plus is also given. It is 0.01. Since we have the square here, I am putting the square. Okay, now on solving this, we will get 10 to the power 3. Okay, on solving this, we will get 10 to the power 3. Okay, so this can be written as 10 to the power minus 1. And if you square this, you will get 10 to the power minus 4 here. So minus 1 and 1 minus will get cancelled, and remaining 3 will be there. If this 10 to the power 3 minus 3 goes to the numerator, it will become 10 to the power 3. And this is how we have got this Q value as 10 to the power 3 for this question. Okay. Now, the next step is to find out the E cell. Next step is to find out the E cell. So E cell is equal to E naught of cathode minus E naught of anode. Okay, the reduction potential for both. Minus 0.059 divided by N into log of Q. Okay, this is the Nernst equation. And substitute all the values. So what you will substitute here for this E naught of Ag plus 2 Ag? Ag plus 2 Ag is 0.80 minus of 0.76 zinc reduction potential. Okay, and minus 0.059 by 2 into log of 10 to the power 3. Okay, so now if you subtract if you add 0.80 and 0.76, what you will get? We will get 1.56, right? So in place of this, we will substitute 1.56. And what is the value of log 10 to the power 3? Can anyone give me the value for log 10 to the power 3? Quickly, in place of log 10 to the power 3, what you will substitute, students? Suma, very good. It is 3. So what formula we have to use, my dear? It is log of m to the power n, which is equal to n into log m. Okay, so this is the formula which we are getting from our mathematics. Okay, so here we have log of 10 to the power 3. So it will be equal to 3 into log 10. Okay, and log 10 is equal to 1. So 1 into 3 is 3. So in place of log 10 to the power 3, we have to substitute 3. And if we substitute, we will get the formula and the equation like this. Okay, now after multiplying and dividing, we are getting 1.4715 volt. as the value for E cell, and E cell is nothing but the cell potential. E cell is nothing but the cell potential. So students, can you understand this question? So this type of questions are very, very important for the competitive exams. Okay, for board exam as well as for competitive exams. So they will ask you to find out the E cell value. Please don't interrupt the class, students. So many students are watching. Kindly don't interrupt the class. If you're having any doubt, ask your doubt in the chat box. Got it? So students, concentrate on this type of question where you need to find out the cell potential value. Okay, so you have to apply the Nernst equation and the concentrations given there. Okay, find out the n value, and I told you how to find out the n value also. N is nothing but the number of electrons lost or gained. Okay, so fine. That's all about the Nernst equation. Now let's move on to the applications of Nernst equation. So why, in which place this Nernst equation is being used and for what purpose we are using this? The first thing is, it is used for the calculation of equilibrium constant. What is equilibrium constant? How it is denoted? It is denoted by the letter K. And in terms of solution, it is denoted by Kc. And in terms of concentration, it is denoted by Kc for solution. And in terms of partial pressure for gases, it is denoted by Kp. Okay. Now, at 298 Kelvin, the E cell is equal to E naught cell minus the 0.059 by N to log Q. So this is from a Nernst equation for this particular temperature. At equilibrium, what happens? Q will be equal to the KEQ, and the E cell will be equal to 0. So yesterday we have studied, right? At the equilibrium condition, delta G will be equal to 0, and because of that, E cell will also be equal to 0. And if I substitute E cell is equal to 0, what I will get? 0 is equal to E naught cell minus the entire term with the log of KEQ. In place of Q, I am substituting the equilibrium constant KEQ. Okay. And bring this entire term to the other side. So we will get a positive term. So E naught cell will be equal to plus 0.059 by N into log of KEQ. So this is the equation or the formula which can be used to calculate the equilibrium constant from the Nernst equation. So we have started with the Nernst equation and we have arrived at the equilibrium constant relation. Got it? So this is the important formula which you have to note down. Okay. Shall we go with one problem, numericals based on this? Want me to repeat? So listen carefully. This equation is Nernst equation. Okay. This is the Nernst equation. And at equilibrium, Q is equal to KEQ and E cell is equal to 0. Okay. Substitute that value here in the Nernst equation and you will arrive at this new equation. Now bring this entire term to the other side. So it will become positive plus 0.059 by N into log KEQ. That's all. Is it clear now? For the person who is sitting behind the ID, Mr. Mr. Can you able to understand? Change your ID to your name. Is it okay now, my dear? Yes. Okay. Now, students, we'll go with one numerical. Okay, we'll go with one problem. Yeah, this is the question. Calculate the equilibrium constant for the cell reaction zinc plus copper 2 plus giving zinc 2 plus copper at STP. What is STP? Standard temperature and pressure. and the E naught cell is given as 1.1 volt. Now, how we have to arrive at the answer? Take the equation first. Take the equation first. And for this, for finding out the KEQ, we need the value of N, right? We need the value of N. E naught cell is already given. We need the value of N. What is the value of N for this equation? How many electrons are lost? Very good. It is 2. Number of electrons lost is equal to 2. Very good. So now I have told you the condition is STP. So what is the standard temperature value? Can anyone tell me the standard temperature value and the pressure value? Standard temperature means what is a Kelvin? How many Kelvin? What is standard temperature and pressure? What is the standard temperature and pressure? 273. My dear, in terms of Kelvin, you have to give no? In terms of Kelvin, the standard temperature is 298 Kelvin and the standard pressure is 1 bar pressure. Okay, so don't forget. So keep this, put this values in your mind today itself and now itself. Okay, standard temperature is 298, standard pressure is 1 bar. Not only with this lesson, for the entire chemistry physics, you have to use this only. Got it? Now, take the equation formula which relates E naught cell and KEQ. So from this equation only we are going to find out the KEQ value. Substitute all the given terms. E naught cell is 1.1, N value is 2. So after substituting we will get this step and keep log Q, log KEQ one side and bring others to the other side. So 1.1 into 2 divided by 0.059 is equal to log KEQ. So after multiplying and dividing, we will get 37.29 as the answer for the entire that term. And bring this log to the other side. It will be the anti-log. Okay. And anti-log of this 37.29 is 2 into 10 to the power 37. Okay. So don't worry about the anti-log. If such kind of question is asked to you in the competitive exam, they will give you the anti-log value also. Okay, so don't have to worry. Otherwise, they will ask us to find out the log KEQ value. Okay, instead of KEQ, they can ask us to find out log KEQ value. And you don't have to go for the anti-log calculations. Okay, because we are not provided with the log tables in the examination. So you don't have to worry. Got it? So is this question clear to all of you? So we are just taking one equation and substituting all the required terms. That's all. Okay. So here the Nernst equation and the applications of Nernst equation is getting over. So some limited problems alone I have discussed today. So we will solve many numericals from the part which we have studied till Nernst equation. From electrode potential, from cell potential, Nernst equation, and from electrochemical cell. So we did not solve much problems from those parts, right? So we will take one day and we will solve many questions from these topics. Okay, so now we will go with one more topic which is called as electrolytic cell. Okay, so what is an electrolytic cell? So here I have two objects. Okay, and I am going to take a container, and inside this container, two electrodes are dipped. Okay, so it can be the metal electrode. Okay, so what is the first one? The first is one electrode, or I can call that electrode as the impure copper electrode. Impure copper electrode. And the second electrode is called as pure copper electrode. Okay, pure copper electrode. They are connected with a DC source, and the electrolytic solution is called as copper sulfate salt solution. Copper sulfate solution. So in copper sulfate means we will have Cu2 plus cation and SO4 2 minus anion. So these are those ions. These are those ions. They are moving inside the solution, and the negatively charged ions are moving towards impure copper electrode, and the positively charged ions are going towards pure copper electrode. Okay, so these are the objects which contains the copper metal. Okay, now at anode what happens and at a cathode what happens? So yesterday itself I told you at anode oxidation occurs. At anode oxidation occurs. So oxidation means this is a reaction. Okay, copper metal electrode will lose two of its electron and it will get oxidized. And at cathode, what happens? Reduction happens. The copper 2 plus is gaining those two electrons and it is getting converted to copper. So this is what is happening inside an electrolytic cell. So this particular cell is called as electrolytic cell where we have two electrodes inside the same container. So far in the galvanic cell, we took two different beakers and we have connected that into the with the salt bridge, right? So those types of cells are called as galvanic cell. And here if two electrodes are dipped inside the same container and this is called as electrolytic cell. And the process is called as electrolysis. Okay. Now based on this electrolytic cell and the electrolysis process, we are going to study two laws which are called as Faraday's laws of electrolysis. Okay, so we have two laws under this, and this person is Faraday, and he gave two laws. So now we are going to look into the first Faraday's first law of electrolysis. It is the amount of chemical reaction which occurs at any electrode during electrolysis by a current is proportional to the quantity of electricity passed through the electrolyte. So we have a beaker, we have an electrolyte which is called as electrolytic solution. Okay. Now the quantity of electricity passed through that electrolyte is proportional to the current. So amount deposited or liberated is directly proportional to the current which is supplied or the charge which is supplied. Okay. If the amount deposited is more, then the charge supplied is also more. If the amount deposited is very less, then the charge supplied is also very less. Got it? So the amount is denoted by the letter W and the charge is denoted by the letter Q. So mathematically, W is directly proportional to Q. And we know that Q is equal to I into T. Okay, so where I is the current and T is the time. So in place of Q, if we substitute I into T, relation, okay, from the first relation. And if proportionality symbol is removed, we have to introduce a constant, right? And that constant is called as Z here. That constant is called as Z. So W is equal to Z into I into T. Z into I into T. So this is the final equation where Z is the electrochemical equivalent of a substance. It is calculated using one formula which is E by F. Okay. It is E by F. Very important thing you have to note down. Where E is the equivalent weight of the metal and F is the Faraday's constant. Okay. Equivalent weight of the metal will be given to us in the question. Or we can also calculate. Got it? I'll teach you how to calculate. So students, this is the equation for first law of thermodynamics. W is equal to Z into I into T. If Z is not given directly in the question, then we have to calculate using this E by F formula. Okay? Clear? Can you able to understand the Faraday's first law? Shall we solve one question based on Faraday's first law to understand this concept better? Yes. So here is a question. A current of 1 ampere was passed through a solution of zinc sulfate for 30 minutes. Find the weight of the zinc deposited on the cathode. So what we have to find out? Amount deposited. The W, weight we have to find out. W we have to find out. So what are the other given informations in the question? We are provided with current value, I value, and we have time in terms of seconds. And also keep one thing in your mind, time should be given in terms of seconds, not in terms of minutes, okay? So if it is given in terms of minutes, we have to convert that into seconds. So we have I and we have T. Now we have to find out the weight of the zinc. So let's start with a time conversion first of all. So time is equal to 30 minutes. Each minute contains 60 seconds. So 30 into 60 will be 1800 seconds. And we have to find out the equivalent weight. We have to find out the equivalent weight to get the Z value because Z is not given in the question. So we have to find out we have to find out E and F is known. Okay, F value is 96,500. It is a Faraday's constant. E is find out by the atomic mass divided by valency. Equivalent weight of the metal is calculated using atomic mass divided by valency formula. So take down this formula in your notebook. So what is a metal here? Metal is zinc. Sulfate is the salt and zinc is the metal. So the atomic mass of this particular zinc is 65 and the valency of this metal is 2 because we will separate this into zinc 2 plus and SO4 2 minus, right? So the number of electrons lost or the valency for zinc is 2. So it is 65 divided by 2, which is equal to 32.5. So you may ask me that, ma'am, how do I know that the atomic mass of zinc is 65? So that kind of questions may come into your mind. So you should memorize the atomic mass for some elements which are given there in the periodic table. Okay, and one among those very important element is this zinc. Okay, if you do not know the atomic mass of this zinc before, from today onwards, keep this in mind. Okay, atomic mass is 65 for zinc. And what is the current value? It is 1 ampere, and the Faraday's constant is 96,500. Coming to the first law of electrolysis, W is equal to Z into I into T, where Z is equal to E by F, and substituting that value, we will get E by F into I into T. Substitute all the values. E is equal to 32.5 and Faraday's constant is 96,500. I value is 1 ampere and time is 1800 seconds. Conversion factor is very important, okay? If you make any simple silly mistake in here in the time part, your entire answer will go in a wrong way, okay? So you have to be very careful in the conversions for physical chemistry, for all the physical chemistry lessons. Okay, you may know the formula, you may know how to apply it and all. But if you forget to convert this, if you're not converting any factor, then it will go in vain only. Okay, so try to convert the things properly and then go with the formula and for the final answer. So by multiplying and dividing, we are getting 0.606 gram as the value for the weight of zinc deposited on the cathode. Okay, is it clear for all of you? Did you all take down this formula, which is being used to find out the equivalent weight of the metal? Yes? Yes. Okay, very good, students. So we are about to go with the Faraday's second law of electrolysis. So the next topic is Faraday's second law. To understand this Faraday's second law, I'm going to take a zinc sulfate solution inside a beaker where two electrodes are dipped, and I'm going to take one copper sulfate solution in another beaker, and those two cells are connected. Okay, now the law states that the amount of different substances liberated by the same quantity of electricity passing through the electrolytic solution proportional to their chemical equivalent weight. So quantity of electricity means it is I. Who is that? Please don't unmute yourself, students. Kindly mute yourself. Yeah. Quantity of electricity passed is proportional to their chemical equivalent weight. So W1 is equal to Z1 into I into T, where Z1 is equal to E1 divided by F, where E is the atomic mass divided by valency. And for W2 for the second beaker, it is Z2 into I into T and E2 by F into I into T. Okay, so we are getting two relations where they are related to their equivalent weights. Okay, now if I take the ratio, if I take W1 divided by W2 and substituting all the given terms, So IT and IT will get cancelled because they are same, and F will also go away, okay, because they are same. So W1 by W2 is equal to E1 by 2. So this is the Faraday's second law of electrolysis. Got it? First law means W is equal to Z into I into T. Second law talks about two system. W1 by W2 is equal to E1 by E2. Got it? This is clear for all of you. So take down this formula under Faraday's second law of electrolysis. So this is the definition and this is the formula. Okay, students. So today we have studied Nernst equation, applications of Nernst equation. In that application, we have solved some problems related to KC and E cell, E naught cell, and after that, I have explained about the electrolytic cell and Faraday's first law and second law. Okay. Now, we did not solve any problems related to second law, right? So we are running out of time. So we have to wrap up the today's session. So we will continue the next session with the Faraday's second law problems, and then we will move on to the next topics. Okay. So do any of you have any doubts from the today's class and from the today's topics which we have discussed so far? No? Okay. Okay, sir. So only Sakshi is replying. Others are not replying at all. Uh, okay. Only when I ask, you guys are replying. Try to interact. Don't get scared. Okay. Okay, students. Thank you. Thank you so much for listening to today's lecture. Meet you all tomorrow. Okay. Bye bye. Thank you. Yes, Tejaswini, it is available on YouTube also. You can watch from there also. Okay, it is available there. From today onwards, you can go through that in the YouTube also. Okay, students.